In this video, we're going to go through an example where we graph a function by writing it in standard form. We're going to find the vertex, axis of symmetry, and the x and y intercepts. So when I get started with this, the first thing I'm going to do is I'm going to rewrite it where I have the highest power of x, and then the second highest power of x, and the term that has no x. Okay, so I just like to get it into that format first, so I always rewrite it if it's mixed up to begin with. Alright, remember, so we're trying to get this into standard form, which looks like a times x minus h squared plus k. Okay, so that's the format that we're trying to get it into. So this is, a complete square. So the first thing I'm going to need to do is get this function. I need to complete the square for this function. Okay, so to complete the square, first thing I'm going to need to do is get x squared by itself. So I'm going to pull out the negative 2, x squared, and then I'm going to have this as plus x. I'm just going to pull it out of the first two, and then I'm going to leave the plus 6 at the end though. Okay, because, well, I have a plus k out here, so it's okay to have extra stuff out there in the back. Okay, let's see. Let's remember what completing the square is. So remember that, I always write it like this: x minus or x plus k squared equals d, which is the same thing as x squared plus 2xk plus k squared equals d. So the goal is to get it into this format, and then once you have it in this format, you can find the complete square format like this. Okay, so I'm going to go ahead and do this. I have negative 2. So I have this x squared that matches this x squared here. So I'm going to write that x squared plus. I need it to be 2x times some number k. So I'm going to write 2x, and then I'm going to say 1/2. Okay, you see the 2 cancels, and you're left with just x. So that's what you see here, just the x. And then I'm going to add on this final term, this plus k squared. K is 1/2 because it's here, it's 2 times xk. So k is this 1/2 squared. All right. If I add it, though, I must also subtract it, so I'm going to write that too. Okay. And then I have out back, I have a plus 6. Okay. So this is x squared plus 2xk plus k squared, right? So it's in this format. So I can rewrite it in this format. These two are the same thing. So I'm going to do that. I'm going to write that negative 2 and then x plus k. So k is 1/2 squared. Okay. But then I still have this negative 1/2 squared, right? That's coming from right here. So that guy is still there, and he's inside the parentheses with the 2. So I need to make sure I keep those parentheses. Then I have plus 6. Instead of writing it as 1/2 squared like that, I'm going to actually change it up. I'm going to write it as minus 1/4, right? Because 1 squared is 1, 2 squared is 4, so that's minus 1/4, the same thing as 1/2 squared. Okay, now I'm going to bring that 1/4 outside of the parentheses. So to do that, I'm going to have negative 2. So I'm going to distribute the negative 2 basically. So I'm going to distribute it in here. So, well, it's going to be on the outside here. And then multiply it here. So I'll have negative 2 times x plus 1/2 squared. And then I'll have this minus 2 times 1/4 plus 6. Oh, plus 2, because this was minus and that's minus. Minus 2 times minus 1/4 is plus. Okay, so this is negative 2, x plus 1/2 squared. Okay, 2 times 1/4 is 1/2, right? The 2 cancels and that becomes a 2 on the bottom. Okay, plus 6. 6 is the same as 12 halves, right? And then let me rewrite this. Okay, so now since these two have the same on the denominator, same bottoms, I can add what's on the top. So that would be 13 halves. All right, there we go. This is the standard form of the equation. So what is the vertex? The vertex then is, so remember, this is standard form is up here, and it's minus h, right? So if it says plus h, then this must be negative. So the vertex is negative 1/2, and then 13 halves. Okay, so I ran out of room there, so I went ahead and transferred everything here. So this is our standard form of the function, and we found that the vertex. Next thing is, let's find the axis of symmetry. All right. So the axis of symmetry is the x coordinate of the vertex. Okay, so it'll be x equals this negative 1/2. That'll be the axis of symmetry. And then we need to find the x-intercept. Okay, so to do that, I'm going to plug in 0 for y, and then solve for x. So let's go ahead and do that. So subtract 13 over 2 from both sides. So I'll have negative 13 over 2 on this side, then I'll have negative 2x plus 1/2 squared. And then I will divide both sides by negative 2, so that'll get us 13 over 4 equals x plus, it'll be positive because positive divided by or negative divided by a negative is positive, so that'll be positive. And then plus 1/2 squared. Okay, so then I will take the square root of both sides, so plus or minus the square root of 13 over 4 equals x plus 1/2. So this is plus or minus the square root of 13 divided by 2 equals x plus 1/2. Okay, plus or minus the square root of 13 over 2. Subtract off 1/2 from both sides to get this equals x. So there's two x-intercepts. I'll write them in red. So we have the positive 13 divided by 2 minus 1, right? If I can combine what's up top here. So there's the positive square root of 13 minus 1, and then, so comma 0. And then there's the negative square root of 13 minus 1 over 2, comma 0. Okay, so next let's find the y-intercepts. So there's the x-intercepts, let's find the y-intercepts. So let's plug in 0 for x. So I'll get y equals negative 2, 0 plus 1/2 squared plus 13 over 2. So that is negative 2, 1/2 squared plus 13 over 2. That is negative 2 times 1/4. Okay, plus 13 over 2. This cancels, and that makes that a 2. So that'd be negative 1/2 plus 13 over 2, which is 12 over 2, which is 6. So the y-intercept is, I'll go ahead and write this in red, is 0, 6.